I'm Shane Mitchell, I'm the CTO here at Artimus Robotics, and today I'm going to walk you through how to use our multi-channel high voltage amplifier. All the information I'll present in this video can be found on our documentation website. There, you'll find everything you need to know regarding setting up and programming the amplifier. To get started, we'll connect the peripheral components detailed on the Hardware Overview tab. The core components of the setup are the amplifier itself. This is the 8-channel model that consists of 8 independently controllable high voltage outputs. Next, we have the input power adapter. This converts the 110 to 220 AC voltage from the wall to a 24 volt DC to power the amplifier. Plug the input power adapter into the wall outlet and then to the barrel jack input plug labeled power on the amplifier. Then there is the micro USB cable that provides serial communication between your computer and the amplifier to digitally program the amplifier. Connect the micro USB cable to the port labeled serial on the amplifier and connect the other end into the USB isolator. The USB isolator helps protect the USB port on your computer from errant electrostatic discharges. You can plug the USB isolator directly into the USB port on your computer. Next, we have the HDMI terminal block. This is an optional component that enables real-time monitoring of the output voltages and current. On the Hardware tab, you can refer to this pinout for your desired connections, and these scaling functions to convert the measured values to the actual outputs. For this demonstration, I'll be using an oscilloscope to monitor the voltage of channels 1 and 2, which are these pins here. And lastly, we provide high voltage cabling to safely connect loads to the amplifier. These cables are rated to 20 kilovolts DC. Connect the high voltage return cable to the threaded port on the side of the amplifier labeled high voltage return. Then connect the loads using the 2mm banana plugs and the provided cabling. Here, I'll be using both our encapsulated E-series expanding actuator and the C-series contracting actuator. With everything connected, we are now ready to turn on the amplifier. Locate the rocker switch on the side of the amplifier labeled main power and toggle that to the on position. You'll notice the orange power light will illuminate as well as the light labeled high voltage off. If your computer audio is on, you'll hear an alert signifying a USB device has been connected. Now we need to install the Artimus Robotics Device Interface, or ARDI, to program the amplifier with Python. Refer to the Getting Started tab on the documentation website and ensure your computer has an installed version of Python 3.0 or newer. Then, download the ARDI package from our GitHub repository. In the repo, this is the file ending in .tar.gz. Go to the downloaded file and copy the file path. Then open a command line and in the terminal type pip install and the copied file path. Once installed, ARDI can be run from the command line as an interactive Python session using the command python-i-m ARDI. Note the version number of ARDI, as well as the firmware version that's installed on the amplifier. Be sure these are the most recent versions that are posted on our GitHub repository. Using ARDI, we can now program the amplifier with our API. The API is primarily defined on the Unipolar Operation tab, the Bipolar Operation tab, and the Parameters tab on our website. For this demonstration, I'll be using the Unipolar Operation API. First, we'll need to specify the rail voltage, which defines the maximum operating voltage of each channel. This is one of the few parameters that is not controlled digitally. To adjust the rail voltage, locate the potentiometer slot on the side of the amplifier enclosure labeled HV Adjust. With the ARDI interactive session running, I can continuously print out the rail voltage using the command rail.echo vmon. With the high voltage switch in the off position, the rail voltage reads 0 volts, or nearly 0. When I toggle the high voltage switch on, you'll see the rail voltage jump to the set value. I can use a small screwdriver to turn the potentiometer and adjust the rail voltage accordingly. It is recommended to set the rail voltage just slightly above your desired operating value. In this case, I'll set it to 7,000 volts, and once it's set, it does not need to be adjusted again unless the required operating voltage is substantially different. Now I can program the voltage waveforms. On channel 1, I'll be using a chirp signal that varies in frequency from 0.25 Hz to 5 Hz over the course of 2 seconds with an amplitude of 5,000 volts. For channel 2, I'll apply a 6,000 volt square wave at 1 Hz. Now the waveforms are loaded to the amplifier. When I toggle the high voltage switch to the on position, the waveforms will be applied to the designated channels. You can see the expanding actuator on channel 1 is following the chirp signal, and the contracting actuator on channel 2 is following the square wave. These waveforms will run indefinitely unless programmed otherwise. I can stop the amplifier by toggling the high voltage switch to the off position. This will immediately discharge all of the output channels. I can also use ARDI to set the output voltages to 0. Now I'd like to take you through a more custom Python script that controls the output channels using an analog input signal from a function generator. For this, I've programmed an Arduino to read in an analog input signal from a function generator, then map that input voltage to a high voltage value. In this case, 0 to 5 volts is mapped to 0 to 6,000. And then I print the mapped value to the serial monitor using the Arduino code. I've made a custom Python script that uses ARDI to set the output voltage of channel 1 based on the red values from the serial port of the Arduino. This code requires 2 USB serial ports, one to read the values from the Arduino and the other to send commands to the amplifier. When I run this script, you'll see the ARDI session load in the command line and confirm that the script has loaded correctly and is communicating with the amplifier. The script then indicates that it is ready for high voltage to be turned on. Once high voltage is turned on, the amplifier will immediately output the high voltage waveform to the specified channel. In this case, I'm using channel 1 with the E-series actuator. The input signal is displayed in green, and the actuator voltage monitor is in yellow. Notice that the actuator voltage follows the input waveform from the function generator. I can change the frequency of the waveform and the waveform itself. Here's a shift from a sine wave to a square wave. And now a triangle wave. And of course, I can change the amplitude and the offset of the waveform as well. I hope you found this video informative and it gave a glimpse into the capabilities of our amplifier. This was not an exhaustive demonstration, so please refer to our website for a complete list of capabilities. We are also available for support if your programming requirements are more advanced. If you have any questions or would like to contact us, reach out to info@artimusrobotics.com. That's it for today, and thank you very much for tuning in.